First of May 2007, a group of maths and physics students pilgrimage to Stonehenge to explore the history and mathematics of this ancient monument.
The first phase of Stonehenge was built in 3000 BC.
The large stones were erected 800 years later. Its design was altered many times and in the end was left unfinished.
So that's the equator there. That's the equator and that's the North Pole. That's where all the ice is. So we're working out the azimuth of sunrise on the summer solstice of 2007.
The azimuth?
Yeah. The azimuth is an angle, the number of degrees east of true north, yeah? The math is a bit of trig. And we're kind of looking at the sun, okay? So we're kind of eyeballing the sun like that, okay? And what we want to do is to find out. So using this formula.
In the course of the day, the sun traces out a circle in the sky.
Here, we're finding the angle the sun track makes with the horizon. Well, the perfect horizon, in fact.
Imagine the Earth was just a smooth sphere, no hills or mountains in the way. What you'd see then would be a perfect horizon. You can then put all this together to get a graphical model of the rising sun. If you really wanted to, you could then model the real horizon on the computer.
That would help you work out where the sun would rise, because in reality, the horizon isn't perfect. It's all lumps and bumps.
So we know the direction of summer solstice sunrise, theoretically. But can you practically find this direction? The obvious answer is by using a compass. But compasses are pretty inaccurate. You've got magnetic anomalies all over the place.
So how about using the sun? That's what we're doing here, using a theodolite.
What is a theodolite?
A theodolite is a scientific instrument which is used to measure horizontal angles and vertical angles. You can use a theodolite to measure the angle of the sun above the horizon.
So how about 5,000 years ago when Stonehenge was being built?
Well, the sun at summer solstice would have risen in a slightly different direction, a little more to the north.
How come?
The Earth spins. Because the tilt of the Earth changes slowly over millennia. It's called the obliquity of the ecliptic. It gets more and less and more and less, okay? This also had an effect on the ancient climate, causing the cycle of glaciations and thaws.
Well, all of the holes surrounding Stonehenge, they form a perfect circle. I never even knew those existed before. They form a circle around the main stone circle. There's a few different theories about them. Some people say that they could actually match up with the alignments of all the sun and moon and everything at certain times of year. Other people think that, I think I heard something about some bodies were inserted in there or something like that. I'm not sure about that one though. It's quite impressive how they've actually managed to make this whole thing, how they managed to get everything to work.
It's a lot bigger than it actually looks, and it's pretty amazing, to be honest. It's really sort of weird.
I mean, they didn't have any of the modern stuff that we have nowadays.
Without going into too much detail, the placement of the stones is very precise.
Inspiring.
Fabulous.
It's very old, very historic.
Intriguing.
Awesome.
Pink. Calm. Once in a lifetime.
And it was quite a great sight, quite beautiful.